Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to derive the radius of an orbit in the Bohr atomic model. In the lecture of potential energy, I have taught you that whenever a body revolves in a circular orbit, there are two types of forces that act on it. The one is a centripetal force, the another one is a centrifugal force. Now let's have a look on the diagram. I have made a nucleus and an orbit. A yellow dot is an electron over here. Now the two forces that will act on the electron is the centripetal and the centrifugal. The force that attracts the electron towards the nucleus is called the centripetal force. Is called centripetal force. And the force that takes the electron away from the nucleus is called centrifugal force. In the previous lecture, I have told you that in the postulates of Bohr atomic model that if the electron has to revolve in a stationary orbit, its centripetal force and the centrifugal force must be equal to each other. Now I am representing the centripetal force by a capital letter F with A over here. The FA stands for the force of attraction, and I am writing FC for the centrifugal force. To avoid the confusion, I have taken the centripetal force to be the F and a small a. A stands for the attractive force between the electron and the nucleus, and centrifugal is represented by FC. Now let's talk about these two forces separately. Now I'm talking about the force of attraction. I'm applying the Coulomb's law over here. I'm applying Coulomb's law. Now Coulomb's law, what does it says that the force of attraction between the two charged particles is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of distance between them and a proportionality constant, that's called the constant of permittivity for air or the vacuum. Now let's talk about what's R over here. What's our R over here? It is the distance of orbit from the nucleus, that's small r. Now let's talk about the charges. I'm writing now what is Q1 over here? It's the nucleus, obviously. I'm writing nucleus. What's the charge on nucleus? It's plus Ze, where Z is the number of proton and E is the charge on proton. Positive sign, obviously it's a proton, that's why it's a positive. And what's my Q2 is the charge on the electron, so it comes out to be E. I'm ignoring the signs of the nucleus and the electron for the timing for the calculation. Now I will put the values of Q1 and Q2 in the formula. Fa comes out to be K. What's my Q1? It's Ze. What's my Q2? It's E. You can write negative over here. Now divided by small r square, the force of attraction comes out to be K Z E square divided by small r square. Now let's talk about the centrifugal force. The centrifugal force has the formula of mv square divided by small r. What's m over here? It's the mass of electron. What's v over here? It's velocity of electron in that orbit. And again, was r is the radius of the orbit, and that's the same thing in the force of attraction, thus r is the same. Now, Bohr sir told in his postulates that the centripetal force, that is Fa, must be equal to the centrifugal force, that is Fc. So it comes out to be, I'm putting down the values. The centripetal force is K Z E square divided by small r square, and the centrifugal force is m v square divided by small r. So I have just taken the values. Now I will evaluate it. You can see that this r and the square has cancelled, and it comes out to be k z e square divided by small r is equal to the m v square. Now mark this equation to be the number 1. Now let's talk about the second postulate or third postulate of Bohr atomic model, in which he has said about that the electron will revolve in the stationary orbit, and stationary orbit will that whose angular momentum is quantized. Now I'm writing according to Bohr sir, electron will revolve in stationary orbit. The electron will revolve in stationary orbit, that is orbit whose angular momentum whose angular momentum is quantized. That is, angular momentum is m v r. It must be whole number multiple of h upon 2 pi. Now take that whole number to be the small n. So now this is the equation given by Sir Bohr. Now on squaring the both sides, I'm squaring the both sides. On squaring the both sides, we will get m square v square r square equal to n square h square upon 4 pi square. We have squared the both sides. Now you can write this equation like m into v square into m into r square is the same thing. Comes out to be n square h square upon 4 pi square. Now what next I will do? I'm going to put the value of mv square from this equation over here. So it comes out to be kz e square by r, k z e square by r into m into r square comes out to be n square h square upon 4 pi square. Now you can see that this r gets cancelled out by the square. So my radius here, my thus radius, it comes out to be n square into h square divided by k z e square into m into 4 pi square. It comes out to 4 pi square z e square km. Yes. So this is the formula. The exact formula for the radius of nth orbit, it comes out to be the n square h square upon 4 pi square k z e square m. So this is the formula for the radius of stationary orbit in which the electron will revolve. Now here you can see that, you can observe that I am writing the radius of nth orbit I am taking n square here divided by z. I have just separated out n square and the z. The rest I am left with h square divided by 4 pi square k e square m. Now accept n square by z. There all the rest values are the constant values. You can see that. From here you can observe that the radius of nth orbit is directly proportional to the n square and inversely proportional to the z. As the n increase, that is, as the orbit number increase, the radius of orbit will increase, and inversely proportional to the atomic number. Atomic number stands for the number of protons in the nucleus. More the protons, more the attractive pull with the pull the nucleus will have on the electron. So it will decrease the orbit's radius. So more the proton, more will be the strong attractive pull by the nucleus for the electron. So the radius of orbit will then decrease. Now let's put the values of all the constant. I am taking the radius of nth orbit comes out to be the n square divided by z. Now what's the value of h? It's Planck's constant. It's 6.626 into 10 raised to the power minus 34 square divided by is 4. What's the value of pi? Is 3.14 square. K is a constant of permittivity. We used to take the air or vacuum in an atom, so value comes out to be 9 into 10 to the power 9. E, what's E? Is the charge of the electron. It comes out to be the 1.6 into 10 to the power minus 19 square. And what's the M? M is the mass of the electron. It comes out to be 9.1 into 10 raised to the power minus 31. Now that's all the values of h, pi, k, e and m. So now let's evaluate it. After evaluating, we got radius of nth orbit comes out to be the 0.529 into n square divided by z. So this is the formula for the radius of the nth orbit, but its units will be in the angstroms. So the radius of nth orbit comes out to be 0.529 into n square by z in angstroms. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.